Thank you. So, hello and welcome. As it's been said, my name is Honza, and today I want to share with you sort of my journey through time and how I came to use what I use and what was the steps, like how I started, and also what lessons I derived from my successes and my failures, which were unfortunately a lot more common. So it is not a journey through my time as I progressed through my career or through the project that I was involved in, but also what I believe should be an evolution of any single project. What are the necessary steps? So first, for me, and also for a lot of the other projects out there, what is the past? Where are we coming from? For me, the past is this big iron, big data warehousing enterprises. My first job was 10 years ago now, working with a SQL database that had 6 terabytes. That was unbelievable at that time. I couldn't imagine that I would ever own a device where I could fit that amount of storage in my pocket. So that was sort of what I learned from that experience, that SQL databases are all powerful and almighty and all expensive, and they can do anything, and there is no reason to ever do anything else. Like, it just works, right? You just buy huge hardware, millions on licenses, and you're all set. But then I moved on. And my next job was working with Django, which is a web development framework. So I moved from the enterprise world, from the enterprise data warehousing, to the web development stuff. So needless to say, there were a lot less money going around. So when I said, oh, that's easy, we just buy this big box. And like, what? That's more than our entire IT budget for an entire year. And this is just one 2-week old project. That couldn't fly. So obviously some lessons were not transferable. So now let's start from the beginning. When I approach a new project nowadays, there are first several stages that I go through and that the project goes through as well. The first stage is very simple, and because simplicity is what it is. It is to optimize for developer happiness. I don't care how big your project will be 2 years from now or 2 days from now. Right now, it's super simple. It should be super simple. And the people that you need to make happy are not your customers, are not your operations people. It's your developers. Everything needs to be easy. Everything needs to be easy to set up. So that's sort of the first thing. When I started working with web, there are a lot more people involved. It's not just back-end developers. It's also the front-end developers, the designers, everything around that. And some of them might not be so keen on trying to set up Postgrad and Kafka and everything on their computer in terms of start development. So that was sort of the first lesson that I learned the hard way. We created a command that was actually called Mumbo that was run every single day. Every developer came to work, and the first thing that they ran was Mumbo Jumbo. And that actually set up their entire environment. It set up Postgres for them and Redis and everything else. And that taught me that that's the most important thing. They need to be happy and they need to be productive. So that ties closely to the second part, like, don't over-engineer things. Like, even if you feel that you have to, even if you absolutely know that you will have to do that in the future, don't start with it. Stick with the developer happiness. Just start simple. So for all the projects that I start, even when I know that they're going to be huge and that they'll have millions of users, I start with a SQLite as database, if I even need a database. Which is the first question that you need to ask yourself. Do you actually need a database? I know several successful projects that was a project that when I showed it to you, you would automatically say, oh yeah, start with the database and go from there. But instead they started with a bunch of data in Python dictionary somewhere on disk. It was super fast, They couldn't change it, but it turns out they didn't need it. Just because they postponed the decision what database to choose, they found out that they don't need any. So that's the first part. Like, don't over-engineer. Don't go for databases that you don't need right now. Start simple. The same goes for the SQL schema. This is actually the simpler version of the schema that we ended up with after several iterations. We started with something that would have not even fit on the slide. This does fit there, but it's still not readable. And this is just a super simple CMS. Like, it's not rocket science. But we started with, we will have all these, demands from the product side. We need to account for them now. And that was one of our biggest mistakes, and we'll see later how it turned out. So that was sort of the first stage. The stage 0 is to optimize for developer happiness, make everything super simple and super straightforward. And what to do now when that's no longer an option? You start running into trouble. Well, at that point, my approach is, or my advice, is exactly opposite. And just use it. Don't treat it as a generic tool. Commit to it, learn what it can do, and make sure that you run with all the options it gives you. And this ties into our favorite Mumbo Jumbo command, because all you need to do is change that command to actually not spawn a new SQLite database, but now starting Postgres. So again, nobody needs to really know. Nothing changes from the outside, but on the inside, you have a powerful database, so use it. Don't use generic tools. Generic tools are very good when you're starting, but they have a very low ceiling. Like, they can allow you to do everything, but everything equally badly. You need to commit to whatever you have. If you have a powerful database like Postgres, and you treat it like MySQL, for example, like you're robbing yourself of a lot of functionality, of a lot of options that you have. Now, some people try to stay as long as possible with the generic tools because they're afraid that once they have to migrate off of the generic tools or off of the database that they're using currently, that the migration cost is going to be too huge. And this is one of the many, many times I'll tell you that is just not true. That is just what people write and what people think. But if you actually sit down and try it, it's oftentimes so much more easier than trying to shoehorn your specific problem into a generic solution. So don't be afraid of the migration. Typically, when you commit to the database and then you find out in the future that was not the best choice, or that you need something else on top of it or next to it or instead of it or whatever, the migration is doable. I've been to several migrations that were complete from different technologies, different schemas and everything, and none of them took more than a week, even when we were talking about millions of pieces of content on a website that had tens of million visits per day. None of those migrations took more than a week of a single developer time. So don't be afraid of the migrations. Commit to your database. But there comes a time, again, where this is not enough. You do have a powerful database and it can do a lot of things. But there are some things where it struggles a little bit. So there comes a time when you need to go in and reevaluate. Can we stick with what we have? Do we need to hire an expert, pay someone to tell us what we're doing wrong or right? Or do we need to invest into more hardware, whatever? One of these cases, which I'll use as example, is this. Anybody knows what the problem here will be for something like Postgres? Yeah? the last page. Very true. I have 80,000 results. They are supposedly sorted by something. If I go to the last page, that means that Postgres needs to read 80,000 records from the disk, sort them all in memory, and give me the last 10. That is not good. And no amount of tweaking of indices can actually help with that unless we do things very specifically. So the first very good question is, like, do we even need this? Like, should we even have the last page? And then the answer is yes. Some people still use search. And we want them to be able to find even the content on the last page. Because, sometimes the droids try to hide. So we still need this. So getting rid of it, which is a perfectly fine strategy, and strategy that is one of my favorites, like getting rid of features is one of the happiest times. But in this case, it's not an option. So we could try and use tricks and tweaks, and we could make sure that we have consecutive IDs in Postgres so we can actually paginate effectively. We could try using all sorts of tricks to sort of pimp out our database so that it can actually do what we need it to do. But at that point, like, is it really worth it? Like, what are we doing here? Like, I don't even know. So that is definitely one option, but it sort of takes you even deeper down the rabbit hole where there is no return. Once you start tweaking on this level, you're super tied in, and it doesn't follow the guiding principle, I would say, of the topic of this conference, and that is always use the right tool for the right job. So instead of having the elephant reach for the grass, because that's the hard thing for her to do, we can just cut the grass and put it into wheelbarrow and feed it to our happy, lazy elephant now. So we can take something, we can take a problem that is super difficult for Postgres, keeping a list of hundreds of thousand records sorted by 7 different criteria and paginating over those, and take something else that is very good at this kind of thing. So in our case, we chose Redis when we had a list in Redis with IDs of all the articles in each list sorted by all the criteria. So we had 10 lists, 15 lists, doesn't matter. And then we used that for pagination. We got back the list of IDs, and then we went to Postgres. So Postgres was just doing its job, the thing that it does really well, just retrieving the things by the primary key, and everything was working fine. Postgres was happy. For Redis, it was also no job whatsoever. And we managed to overcome this problem that was actually regularly killing our site. So now comes a problem of synchronization, and I'll mostly skip over this because the first talk today actually dealt with this problem quite a bit. Here I just present to you one question, and it's one question because I don't actually have the answer. And that is, how do you make sure that what you replicate into the other data store is actually what you write to your primary one? For example, a lot of people tend to write to both data stores concurrently, and that is fine. But what if one of these sort of writes fail? Then you can say, okay, so we can write only after a commit has happened in our primary data store. Yes, but what if you have nested transactions? So you have a transaction that has been committed, but then it's part of a bigger transaction that will get rolled back. So there is a lot of issues here that you need to think through, and you need to make sure that it actually happens as you think it happens. So this is just a brief overview of the synchronization, how to keep these two in sync. And now we're coming to another common pitfall of developers, of what we like to do. The first one was just use generic tools because of the fear of commitment that we all have. The second one is we keep looking for silver bullets. Like whenever I find a new technology, I'm so excited about it that I want to use it everywhere because I can see how it can solve all my problems. So I have here a failed stage 4 labeled the search for the silver bullet. The use of that logo is absolutely accidental. No, it's not. And but it's not necessarily the fault of the technology in question. It is the fault of my own. This was another project that we had that we needed sort of analytics for our application. And again, it was a simple CMS, nothing too fancy. So we just essentially needed to know how many people read which article and which authors have the most comments on their articles and simple stuff like that. And me being a database enthusiast, I read all the blog posts out there, and all of them were raving. This was way back. Raving about how certain databases are great for big data and for everything like that, and how they used it for very similar use cases as I had. So I tried it. That's a few months of my life that I'm not getting back. And the pitfall was that I trusted what people said on the internet. So that is my next. Yeah, I know. But like people do it so often. Like I hear it thrown back at me every single time that I've read that such and such does so and so under these and these conditions. I said, interesting. I've read something entirely different. Should we have coffee now? Like what does that even mean? So don't trust anything and anybody. Test it yourself. It shouldn't be that hard for you to actually cobble up a proof of concept and test it yourself. Don't trust what you see on the internet, as even Abraham Lincoln used to say. That's the problem with the internet. So that was sort of a little detour that I made in my career that I'm a little ashamed of, and that we made here in the presentation. So the next step, the actual stage 4 in the project, is review. So we've had a problem with our data store. We fixed it by adding another. What we need to do now, what absolutely needs to happen, is we need to see the problem that we fixed. Do we have it anywhere else as well? If so, we need to fix it. And also, we need to see if there is anything that this allows us to do that previously wasn't possible. For example, I was describing problems with our CMS with the pagination. We also had forums on the page that we wanted to have sorted by the number of views. But we were super afraid, for very good reasons, to actually be updating Postgres every time somebody reads an article or reads a forum thread. With Redis, that's not an issue. So we took what we have built to solve an actual problem. And we took the very same code and used it to solve something that wasn't a problem, but because we didn't ever do it, because we were too afraid, because Postgres couldn't handle it, or we couldn't handle it with Postgres. I'm very sure that there are people in the world who could do it with Postgres, but we didn't want to become those people, and we didn't have money to actually pay those people. So that's the review part. Take what you've just done and apply it elsewhere. And don't stop there. Keep exploring. Now you have a new piece of technology in your stack. What else does it allow you to do? Is there something in your code or in your product that you wanted to do but couldn't because your technology stack wouldn't support it? Is there something that you haven't even thought of but now is possible because of the technology that you added? In our case, it was the big live show live. It was a live event that was live. It was fairly big. And what it was is it was a live video broadcast, and we wanted to have a real-time chat next to it. And real-time chat, or real-time in general, was something that we couldn't have done before we added Redis to our stack. But now when we added Redis, we went, wait a minute. We have Redis now, and Redis has the blocking pop thing, and it has the publish subscribe, so maybe we can do it. And indeed, we did it. It took 3 or 4 days, and then it took four unsuccessful tries, because we were always like, yeah, we did it. We can chat. Every people in the office can get on it, and it works. Then we pushed it to our users, and 10,000 people came into one chat room, and things blew up. But we've repaired the melted hardware. We've replaced it. We added some scaling layers, and we finally did it. So we had big live show. No, big live show. I always confuse those two. We had 30,000 people in the chat room. It held on nicely, and that is something that we could never have done without it. So always when you add something new to fix some problem that you have, always do the extra step. See where else can it help you. What are the other options that are now open to you that were previously unavailable? And this is interestingly a two-way street. So now I work at Elastic, the company that creates and maintains Elasticsearch. And we're very familiar with this, with people doing this. Because oftentimes, like, people come to us, so we found this feature of yours, and we started using it in this way. And like 1 time out of 10, we go like, wow, we never thought anyone would ever use that in this way. We have people that have large clusters of Elasticsearch without storing any data in it, just because they use the percolator feature. So they use a data store, but they don't store any data in it. And they use it so intensely that they actually need it to run it on 20 machines. It is a safe bet that nobody ever saw that coming. And it actually created a lot of issues internally for us, for the product that we needed to cope with, because somebody did their homework. Somebody saw, hey, I have Elasticsearch. What can I do now? Oh, this is cool. Let's try this. So it is a two-way street. And that's pretty much it. The rest you need to do is keep iterating. Like, keep going round and round. Like, you fix one problem, then you fix the same problem everywhere that you have. Then you explored what other options you've gained by this change. And move on. Like, you're done till the next problem arises. So you have like 5 minutes. The key part, though, is you need to be able to identify what happens and when. So nothing about what I've been talking about would have been possible if we didn't have monitoring, if we didn't know at every stage what's going on, where is the bottleneck, what is actually failing. When our web servers would die every single night at 3 a.m., we wouldn't have known that it is Google actually accessing the very last page if we didn't have monitoring. Okay, that is slightly untrue. We had no idea, so we implemented monitoring, and so we learned that it is just Google accessing the last page. So monitoring is definitely the most important part of maintaining an application and evolving it further if you're running or have reasonable expectation to ever run into any problems like these. So to summarize very briefly the individual steps. Start simple, start fast. Optimize for developer happiness. Nothing beats a simple setup. But make sure that even the simple setup is automated. It will serve you well in the future. Then use what you have. Don't avoid commitment. It is scary, but sometimes you have to do it. The benefits are well worth it. Then identify and fix the bottlenecks that you have. For us, that was the pagination. And finally, explore the solution. See what the solution for the problem gave you, and use everything else that you can use from that solution. Don't just stop there. Don't just apply a patch and move on to the next project. Make sure that you know what else you can actually improve with that piece. Okay, that's it from me. So if you have any questions, now would be the time.
That's it? No more questions?
So we kind of have the opposite problem to you have, in that we're not a data store, but people use us as one. So with things like that, with users coming up with inventive ways to use your platform, like, how do you feel about it? Do you think it's something that should be encouraged and something that you should try and accommodate and build into features, or do you think it's something that you should design your API to prevent?
I'm afraid that there is no simple answer to that. The obvious answer is it depends. Yeah, so it's interesting sometimes when you have an API or something and people take it places where you didn't expect it to go. Like there might be a lot of opportunities there. There are many companies who were started that way. They had an API and suddenly they noticed that the only thing that people use is this part. So they sort of, I'm desperately trying to avoid the word pivot, but yeah. Thanks.
Thanks, Ken.